Hi folks, it's Alan here and I'm in my electronics cave, currently designing a power supply specifically designed for one of my customers. Now, obviously there are plenty of power supplies available and I make several different types, but what this customer particularly wants is a power supply that will completely isolate the equipment they're powering from the mains at all times. And the reason behind that is that the equipment generates quite a lot of electromagnetic interference. So basically I can do two things by isolating it from the mains. One is I stop magnetic interference, electromagnetic interference from the mains going into the equipment, but actually I can also stop electromagnetic interference from the equipment going back out into the mains. So great, battery power supplies can be good, but I'm going a step further. The problem with batteries is they need to be recharged. So I'm doing something a little bit different here. I'm using these things, which you can just see near my thumb here. This is an 18 volt, 2.5 farad supercapacitor bank. Now, supercapacitors are fantastic because they're extremely low equivalent series resistance, so basically you can generate a fantastic power supply from them. The only problem is that they don't actually hold a great deal of charge. Even this whacking great bank, which is 2.5 farad bank, even this is actually only going to hold probably enough for a few seconds, a few tens of seconds, maybe a few minutes of running the equipment at absolute most. So what I'm going to do is use two of these banks. One of them will be on charge while the other one is supplying the load to the equipment, and then every few seconds it will switch over. The problem is that if you're constantly charging and discharging supercapacitors, you have to be a little bit careful about what you're doing. If I simply connect it to my 15 volt power supply as I've got here, then basically you'll instantly charge that capacitor bank at many tens of amps and it will fry the capacitor bank extremely quickly. Similarly, when you're discharging, you have to be a little careful as well. So what I'm designing here is a charging circuit that's designed specifically to gently charge this capacitor bank, or at least relatively gently. So this actually is a circuit that's designed, as soon as I let go of my finger on this button, it will start charging that circuit at about 2.5 amps. And you can see here on my multimeter and my oscilloscope, at the moment the capacitor bank's charged to about 5 and a bit volts, and the oscilloscope is actually displaying the charging current, or at least it will be once it's triggered, once I let go of my finger. And what you should see is as soon as I let go of my finger off this button, the charging will start, and it will start at 2.5 amps. So if I let go of the button, there you go, you can immediately see that the charging current rapidly jumps up to 2.5 amps. There you go, it's currently at 2.3 amps or thereabouts. And you can also see the voltage has started to build up really quite quickly. So I'm currently at 13, nearly 14 volts on the capacitor. Fantastic. And now, of course, when you're reaching the maximum voltage, the current starts to drop down again. So basically what I've got here is a circuit that can charge these capacitors really quickly, but not too quickly so as they will actually damage themselves. And not only that, I can control when it starts charging with a button, or actually in the final version this will be controlled from some control circuitry. So fingers crossed, this is going to make the basis of a really good charging circuit for these, and I'm looking forward to seeing what I can achieve with the output circuitry next.